Hi, I'm Monet Sherman, and I'm presenting to you guys Physics Lab 4. This is the Oscillations Lab. So, a quick table of contents. I'm going to get into a lab introduction, some observations, a data analysis, and some comparisons before ending with our conclusion, our final remarks, and the what does it mean question. So the purpose of this lab is to evaluate the motion of a spring mass system, and it's got an oscillating mass, so the object is to determine whether or not the model follows the energy principle. The result of this lab was it did end up demonstrating the energy principle because the total energy remained constant. No energy was added. And the fundamental principles, as always, Newton's second law. And for this lab, we have the energy principle as well, which states that the change of the energy in the system is equal to the work of the surroundings plus Q. Some other useful formulas that we'll be utilizing, the position update and also like the velocity update as well, and the gravitational potential energy, kinetic energy, and this is the spring, the energy of a spring. The procedure is to use tracker to record the observed motion and then use a computational model from GlowScript to compare these and use it for predictions. The system surroundings, the system here is just going to be the spring and the mass. So this is the video that was observed, or a clip of it from Tracker. And the initial conditions are as laid out here. Observing the video in Tracker and just the video, I got 3 oscillations, and I took the average of that to obtain this for the time. And then using this formula, I found the spring constant, which I then used with the formula for spring stiffness to find the initial weight, the initial length, I'm sorry. These are the initial conditions that I was able to plug into GlowScript to begin using my computational model. And here is where I plugged these quantities in. And here is where I change the energy of the system to be equal to kinetic energy plus the gravitational potential energy plus kinetic energy plus the energy of the spring or force of spring. This is the change of energy versus time. And as you'll see, the energy remains constant. Delta E stays right here at 0. And you'll see this is because the spring energy and the gravitational energy kind of counter each other. So though the energy may be changing, the quantity of energy is not changing. Energy is constant in this system, and it does demonstrate the energy principle. So conclusion, as I just said, the energy principle is indeed satisfied. So no energy has been added, no energy has been removed. And again, like the energy in the system was constant. It was constant at 0. The change of energy was constant at 0. So some sources of error. Of course, we did not account for every single force. There could be other forces that were acting on the object and on the system, and these objects acting on the system could potentially do work which weren't accounted for. So it could be, if everything were to be accounted for, that there would be a different result of this lab. For example, drag force wasn't accounted for. So to follow up, the what if question asks to use the periods of oscillation for the x component and the y component of motion. And surprising, to my surprise, this did produce like a relatively significant difference. It's like kind of offset. And the difference, I believe, could be based on there not being constant or the same forces in both the x direction and the y direction. Again, drag force could be the cause of this. Predicted motion difference could be based on the difference of forces between the X and Y component. And that concludes the lab. Thank you so much for watching.